How?
He is the one.
Look at this. So NASA using long-duration balloons not to spy, but to, well, let's just say science. They fly almost twice as high as the Chinese spy balloon did, around 117,000 feet. Forget about the Statue of Liberty. Actually, some of these are the size of sports stadiums. But what exactly is going on up there in the stratosphere? The Antarctic long-duration balloon campaign, it kicked off this month, launching the first balloon of the season on Monday. Andrew Hamilton is the acting director of NASA's balloon program. He joins us now to talk about this. Andrew, good afternoon. So when we say NASA, a lot of people just think about rockets, but this balloon program, it's some serious business. What's the advantage of using balloons to study space?
Well, balloons provide a very cost-effective and persistent access to the near space environment. No other platform has this capability to get up to the stratosphere and stay there for as long as it does. So the missions that we fly will be there for days or weeks. And if all goes well, this campaign will have a mission that flies over 2 months while it's down in Antarctica.
Which is going to be one to watch, because I know that there might be some record that's broken. We'll talk about that in a bit. When we were talking about this segment, a lot of people thought weather balloons, you know, is this what we're dealing with? But these balloons are different. They're not weather balloons. I mean, as far as the data that's collected with weather balloons, we've got temperature, humidity, pressure all throughout the atmosphere. But these scientific balloons, they have different objectives. I mean, like, for example, mapping the Milky Way, correct?
Correct.
What exactly
the weather
with
balloons
that?
are...
It was on the 11th, right? That I think it was the LoRa balloon that launched, and that's the one that's going to be mapping the Milky Way?
No, the LoRa balloon that launched is a balloon that we're flying for ourselves. It's a technology demonstration mission to help test out some technology that will enable long-duration missions for other science. The one that's going to fly for 2 months is called the Gusto mission. It is intended to help look at the Milky Way and look specifically at the interstellar medium to understand that better, to help comprehend the life cycle of solar systems within the galaxy.
So Gusto's the one that's really making the headlines. I mean, when it comes to the setting, you guys have chosen Antarctica. What makes Antarctica so unique, especially when we talk about NASA's balloon program?
Yeah, a couple of things that help us out with Antarctica. First off is the stratospheric winds. This time of year, they'll set up into a nice circumpolar flow around the continent. It gives us a very predictable pattern to fly around the landmass. The other thing that helps us out, of course, is the fact that it's 24-hour sunlight. You know, it's spring going on to summer down there, so the sun's up all the time. And so with that constant sunlight, that gives you a very consistent thermal environment so that the balloon stays at a relatively constant altitude. So between the predictable flight path and the constant altitude, you get a very stable environment, which allows the science teams and technology teams to gather a lot of data for a very long period of time.
How long has this program been in operation? And with past missions that you guys have completed, what has it helped as far as furthering this particular field of research?
So the program has been around since the 80s in various forms. So it's been around a very long time, and we touch every piece of science out there, between astrophysics, heliophysics, earth science, you name it. We have helped out a lot of different parts of the science community. And many of our programs have gone on from balloon flights to be satellites or go on to the space station as separate experiments. So there's a lot of technology maturation and science demonstration that we help out with.
Well, before we let you go, I know that there is going to be a record that's possibly broken. To imagine 55 days up there is remarkable, especially given the winds and the dynamics as you just talked about. What mission do we need to watch for that long-standing 55-day record?
So that's the Gusto mission. Their science requires them to be up for 55 days. So, and that happens to be our current record is 55 days and a couple of hours. So we're shooting to go well past that and give them as much science as they can get.
Well, best of luck. This is the best time to do it, as you mentioned, from spring to summer, as the sun's going to be helping the entire time. Acting Director of NASA's balloon program, Andrew Hamilton, thanks for your time this morning.